it says sketch the graph of f of x equals x times x plus 3 times x minus 4.5. Then use your graph of f of x to sketch the graph of y equals 1 over f of x. So f of x looks like a cubic, and we know that cubics, the parent function, it goes like this. Okay, so I think you probably won't have too much trouble graphing this. You would just graph your xy axis. You know you're going to have a zero. Well, let's not talk about that yet. You're going to have, for f of x, you're going to have a 0 at, or a root at x, and negative 3 and positive 4.5. So I just, I didn't bother with trying to figure out how far down it goes or how far up it goes. I just know from these three factors, I know that I have x-intercepts. And then I just kind of faked the rest. And then I'm going to go at, because it's just sketching a graph. I'm not being super careful about it. We just got the x-intercepts. So then we're going to look at 1 over f of x, which is a reciprocal function. So 1 over f of x would just be 1 over this function. And I know some things now about rational functions. And because a reciprocal function, it's a rational function. So I know that I'm going to get some asymptotes, some vertical asymptotes, wherever the denominator is 0. So I just went ahead and I looked at the original graph, and I saw wherever it crossed the x-axis, that's where the denominator happens to be 0 now. So I just made the vertical asymptotes. And then I know we also learned, I know it was a hard day when we learned that, but we learned that if it's 1 over, like, well, when the degree of the numerator is less than the degree of the denominator, then we get this horizontal asymptote right here at the x-axis. So I'm just prepared to, when I'm graphing, I'm going to remember that there's a horizontal asymptote there. And then I'm just going to use some things I know. Like, I already kind of think I know what it's going to do. I think that when I put a really giant x number in here, I'm going to get 1 over a really, really big number. Well, 1 over a really, really big number is going to, like, go to 0. So I already know that we're going to go like this. Should have probably used a different color pen now that I think of that. I'm going to use a big old Sharpie so that you can tell which graph belongs to which graph. There we go. I hope it doesn't bleed through. Oh, it does. So then I'm going to look at the regions, because we've been talking about how you can find out whether something's positive or negative in certain regions. So I'm going to look at this region in between 0 and 4.5. So if I just, in my mind, just plug in a 1, I just kind of want to see, I think the graph's going to go, it's going to skip down and go this way. But I just want to check that, so I'm going to check one of these numbers that's in this region, and if I plug a 1 in, I can do this in my head. This will be positive, this factor will be positive. This factor is going to be 1 minus 4.5, so we'll have a negative factor down here. So that confirms my suspicion that the graph was going to go like this. And remember, with asymptotes, the graph wants to get closer and closer to the asymptote, so it's even. And remember, this horizontal asymptote is here, so it can't cross. The graph's not going to be able to cross the x-axis because it's a horizontal asymptote. And then, so typically these graphs, the way they work is they alternate. So I got positive up here, negative down here. I expect it to come up this way, but I can plug in a number in my region just to make sure that it's going to be positive in between 0 and negative 3. So just plug a number in your region, like -1 would work. So that would be negative, positive, negative. So negative times a positive times a negative, this denominator, if I plug in, I mean, if you're not comfortable with negative, positive, negative, you can actually plug the number in and get the actual point. But just by me kind of looking at it that way, I can affirm that the graph's going to go back up this way, positive. There's going to be positive y values in my graph in this region. And then you can probably guess that it's going to probably go back down this way. Remember, we have a vertical or a horizontal asymptote right here. I can plug a number in. So what would that be? 1, 2, 3, -4. So that would give me a negative factor, another negative factor, and another negative factor. So a negative times a negative times a negative would be a negative. So that is going to go this way. So that's where we're getting, it's kind of like it's end behavior and it's asymptote behavior. It's the behavior of the graph without plotting particular points. It's just we're thinking about the behavior of the graph in these regions. And that's what we do with these reciprocal functions and rational functions.